Welcome to Fireman's Technique. Today we are going to do a extremely interesting geometry question. Yes, it's difficult. It's really difficult, this geometry question. So we have a small circle and we have a big circle here. And the center of the big circle is R, and the center of the circle, the smaller circle, is O here. So here we are going to find the ratio between the area. It should be between the area of circle O and circle R. We are going to find the ratio of them. First thing first, we need to know the radius of both of them, right? If we want to find the ratio, we need to find both the radius first. So how can we do that? First, we are going to find the radius of the circle R. We are going to find the radius. And what should we do? And first thing first, I'm going to add a point here. And I'm going to, we already have A, we have B, we have C, we have D. So, also we have O, also we can add a point E here. And then connect. So I'm going to write down, we are going to do the A part here. First A part, wait a minute, it's kinda, the screen is kinda, what? Yes, the A part, we are going to add a point. Add a point E. Add a point E and then connect. This is kind of weird. My spelling. Connect D to E. So here we connect D to E. So our CE is the chord of circle CE of the circle R. Yes, we connect C to E. So C is just the chord of the circle R. This is the definition of chord. If you have 2 points, if 2 points are on the circle and then you connect them, it's just the chord. Yes, this is the definition of chord of the circle in a circle. So here we know that CD is equal to 3. We know that our BD is equal to 4, and then here we are going to get DE is equal to our 3 as well, because this is just the reflection here. Because AB is the diameter of the circle R, so DE is gonna be 3 as well, just the image. So DE is gonna be 3. I'm going to write it down. And we have 2 chords here, C, E, and then we also have a chord AB here, so we can use the chord theorem, which AD line times the length of AD times the length of BD is equal to the length of CD times the length of D. This is called the chord theorem. So we can apply this. AD is the thing we are going to find. AD times 4 is equal to 3 times 3. This is called the intersecting chord theorem. I'm going to just call it as chord theorem here. AD times 4 is equal to 3 times 3. 3 times 3 is equal to 9. And then divided by 4 on one side, we can get AD is equal to 9 over 4. So I'm going to mark AD is equal to 9 over 4 here. So, so what else can we do? What else? Here, I'm going to add a point. We already have E, so I'm going to add a point F here. And I'm not going to write anymore because it's really long. So I'm going to just write down at the point F here, and this F I'm going to add it to this is the point of the circle R here. F is the point of the circle R, and then we are going to connect R to O to F. So R O F, they are straight line here. R to O, if R O F are in the same line, so we can conclude that RF is just a straight line. And yes, they're on both on these 3 points are all on the line RF here. So I'm going to add a point F here and then here, and I'm going to add an extra point here. Add points F. We already have F, so we are going to add a G here, and then I'm going to add a G to here, and then we are going to connect OG here. Here, I'm going to wait a minute. We can find the radius of circle R first, because we know that AD is equal to 9/4, and then DB is equal to our 4, so we can conclude that our radius, I'm going to call the radius of circle R is equal to RR, like that. This radius of the circle R is equal to 9 plus 4 plus 4. This is the diameter, right? And then to find the radius, we are going to divide it by 2, so we can get, let me calculate it by calculator. 9/4 plus 4 divided by 2. You can get this is its radius is gonna be 25 divided by A here. So we can get this equal to 25 divided by A. So radius, so I'm going to name. So we can get RB and our RF are both equal to 25 divided by A, because they are radius. Yes. The reason is radius. So I'm going to name this length as our 25 divided by A here. And then our RB is equal to 25 divided by A as well. And so here I'm going to calculate what is RG here. So RG, we can OG first. We are going to find what is OG, and OG I'm going to name it as the radius of the circle O. Yes, we let OG the radius is radius of the circle O. Name it as RO here. So our OG is gonna be RO, and then OF is gotta be RO as well, because this is radius, the circle of O. The radius of the circle O, yes, its radius is equal to RO here. This OF RO, and then our OR is gonna be the OR. Yes, OR is just 25/8 divided by this radius. So OR is going to be 25 divided by A minus RO. So OR is equal to 25 divided by A minus RO here. So here the last thing we are going to find is our RG. GR is GR. I'm going to name it as RG. So what is RG going to be? So we have a point here, and this CD is the tangent line of this radius. So here. So OG is just equal to this. I'm going to add an extra pawn here. I'm going to add a pawn. We already have F and G, so we are going to add a pawn H here. So I'm going to add a pawn H here, and then our ODH is equal to the radius. Yes, the height is the same. The height of them are same. So OG, which is the radius of O, is equal to DH, which is equal to RO. Yes. And then here is the deal. And DG is equal to RO as well, due to the two tangent theorem. And if this and this are the tangent line of this circle, so this length is equal to this length. So DG is equal to RO as well. This length is equal to this length due to our two tangent theorem. Yes. So DG is going to be RO as well. Yes. RO. This kind of messy, so please forgive me. Yes, this question is kinda confusing. RO, and how can we find RG here? So first thing first, we are going to calculate what is dr here. To calculate dr, we know that this length is 4 and this RB is equal to 25 over 8, so we can conclude that dr is equal to 4 minus 25 over 8. So use our calculator. 4 minus 25 over 8, so we can get this is equal to 7 over 8. So we can get our dr is equal to 7 over 8, and then our dg is equal to our RO. So RG is going to be our RO minus our 7 over 8, which is our dr. So RG is going to equal to RO minus our 7 over 8 here. Yes, 7 over 8. So we already know the length of RG and RO, and also know the length of OR. And the last thing we are going to do, before using the Pythagorean theorem, we are going to prove OGR is a right angle, so we can use our Pythagorean theorem. How can we prove it? Well, yes, our angle OGR is equal to 90 degrees because this is the theorem. Yes, and this is called the tangent line. Tangent line is perpendicular to our radius. Radius, yes. This is the theorem. So we have a triangle here. RGO, ORG. And our RG is equal to our RO minus 7 over 8. And then our OG we let it to be our ORO. And then our OR, what's our OR here? This is equal to 25 over A minus RO. And we prove that OGR is a right angle. Here, to find our RO, we are going to use our Pythagorean theorem. So, our RO squared plus RO minus 7 over A squared is equal to 25 over A minus RO squared. Yes, be careful not to do it wrong here. Yes, you will ruin. Yes. And then first we are going to use the formula. First you square this and then minus 2 times this, so you can get 7 over 4 RO, and then plus 7 over A squared, which is plus 49 over 64, and then here 25 over a square, you are going to get 625 over 64 minus this time 2. So you can get 25 over 4 times RO plus RO square. And then you can look at the equation. Both RO square on both sides, they cancel each other out. And then on the left hand side, you only get RO square. And then I'm going to move this to here. So 25 over 4 minus 7 over 4. You're going to get positive 9 over 2 RO. And then I'm going to move the constant term from here to here. So 49 over 64 minus 625 over 64. You are going to get negative 9 here. Is equal to 0. And then we are going to multiply by 2 on one side. So you can get 2 RO square plus 9 RO minus 18 is equal to 0. And then we can use our calculator. And this calculator can calculate our quadratic equation. If your calculator doesn't have, you can just do it by yourself. And the first result is going to be our 3 over 2. And then our second result is going to be negative 6. And then we are going to reject the value negative 6 since the radius which is referred to the radius and is the length units. The length cannot be equal to a negative number, so we are going to reject our radius is equal to negative 6. So we are going to accept our radius of R is equal to the radius of circle O is equal to 3 over 2. So the question is tell us to find the ratio between the area of circle O and circle R. So the radius I'm going to write here. I'm going to express it as our area of O, circle O, divided by our area of our circle R. Because these two things they are both circles, so they are both similar to each other. So we can just use the formula, just square this, the radius and then square. So the radius of our O is equal to, we already calculated this, equal to 3 over 2. And then we are going to divide it by the radius of circle R, which we have calculated. This is equal to 25 over A. And then use our calculator. 3 over 2 divided by our 25 over A, and then square this. You are going to get 144 divided by 625. And this is not our result yet because we are going to express it in our ratio form. So the area of circle O, the ratio between them are equal to 144 divided by 625. And this is just our result. This is the first part of this question. So I'm going to do the second part here. So the second part, the B part here, wait, M is a point on circle O. So this is the point of circle O. I don't know where it is, so I'm not going to do it. So this is a random point, but I'm going to look at this here. N is a point on circle R as well, and then BN is the chord of circle R. So BN is the chord of this. So I'm going to connect B to N. This is the point of. This question is kind of confusing. Maybe I should fix this. If you know how to fix this question, you can just tell me how to fix this question. I think this is kind of wrong. It means M is the point on circle O. I'm going to name it our M, and then BN is the chord of this, and then n is a point on circle R. This kind of ugly. I'm going to consider this straight line here, and then our this n. Yes, this kind of confusing. If you know how to fix this question, you can tell me in the link in under the video description. So we are going to find, and we know that Bn is just the chord of circle R. This is one of the chord of this chord, so this is a straight line. Bn is a straight line here, and then we are going to find the length of Mn. Yes, we are going to find it. So we know that Mn, we don't know the length of Mn. We are going to find, connect N to M here, right? N to M, and then our M to O, and then we are going to connect O to B. And here I'm going to use we try to use the intersecting chord theorem once again. So what can we do? We are going to find from here to here, from here to here. Yes. Wait a minute. Yes. Here we should have a point here. We should have a point P here. So we will have a point P. I forget about this information. Yes. And then it tells us our OP. This length OP is equal to what? Let me see. Yes, our OP is going to be 5/2. No, 7/2. Yes, 7/2. OP is going to be 7/2. So consider we have a point F here, and then I should write it clearly. This is the point O, and then we have a OF, and then OP is equal to 7/2. I forget this. And then let me see. DP is equal to 7/2. Not OP, DP. So from O to D, first we are going to find from the length from O to D, and then from D to P. From D to P, we already know that this is equal to 7/2. How can we do this though? And here, our DF, this one. And then here we know that our DP is not equal to 7/2, and this is equal to our 3/2. And DP is equal to 2. DP is equal to 2 here. We are given that DP is equal to 2. DP is equal to 2. And then, how can we find the length of our MN? We are going to find what is its length. First, I'm not going to write as much words here because this considered to be a bonus question. So I'm not going to write as much words as this. The first part is the most important part, yes. And the second is a bonus question. I'm going to draw a star here. The bonus question. So let me begin here. So first thing first, OF. What is OF? It's the radius of the circle O. We find this is equal to our 3/2. So let me just write it down. This is equal to 3/2. And then what else do we know? Do we know OD? OD. Do we know this as well? OD. Let me see. OD. It seems like we haven't found OD yet. So we are going to find OD here. So we have a length OD. So OD. This is a right triangle as well. ODG. And then what is our DG here? We know that DG is just the radius. DG is the radius of our circle. Also, this equal to 3/2. DG is equal to 3/2. And then our OG is equal to our radius as well, which is equal to 3/2 as well. And then, we are going to find the length of OD. The length of OD. So OD, we are going to use the Pythagorean theorem. OD is equal to square root of 3/2 square plus 3/2 square. So we are going to get 3/2 square that and then multiply by 2. We get a 9/2 here, and then we are going to square root of that, so we can get our 3/square root of 2 here. And then we are going to simplify it more, so we can get 3 times square root of 2/2. This is called the rationalize. So we can get our OD is equal to 3 times square root of 2/2. OD. 3 times square root of 2/2. So we can know that OP is equal to this length plus this length. We also know that OF is equal to this. And then next thing, we are going to find what is our OM. So OM here, OM, from here to here, we can know that this also equal to the radius of O. So this is also going to be equal to 3/2, OM. And then finally, we are going to find what is BO, OB. We are going to use the Pythagorean theorem here as well. So I'm going to draw a right triangle. This is also a right triangle, and then OG is equal to our radius is equal to 3/2. And then BG here. How can we find BG here? We know that our RB is equal to 25/A, and then we know that RG is equal to the radius of O minus 7/A, the radius which is equal to our 3/2. So I'm going to use 3/2 to minus our 7/A. We can know that our RG is going to be our 5/A. RG is equal to our 5/A here. Yes, we use our calculator, 5/A. RG. And then our BG is just equal to 25/A minus RG, which is 25/A. No, not 25/A minus our 5/A. We can know that our BG is equal to our 5/2 here. So our BG is equal to 5/2, and this is our triangle OBG. To find our OB, what can we do? Use our Pythagorean theorem. So OB is equal to square root of 3 over 2 square plus 5 over 2 square. Use our calculator. 3 over 2 square plus 5 over 2 square. So we can know that this is equal to square root of 17 over 2. So our OB is equal to our square root of 17 over 2. And then finally we can use our core theorem. This length plus this length times this length is equal to this length times this length. And this length, we are going to write this as our mn plus our 3 over 2 times our length of OB, which is equal to square root of 17 over 2, which is equal to the length of OF, which is equal to 3 over 2 as well. And then times the length of this, adding up. So 2 plus 3 times square root of 2 over 2. Here, what can we do here? This is kind of confusing here. So here I'm going to multiply by square root of 17 over 2 here. So mn times square root of 17 over 2 plus 3 over 2 times square root of 17 over 2. And here I'm going to get the same denominator. So 2 times 2, which is 4. So we can get 4 plus 3 times square root of 2 over 2. And at this thing times 3 over 2, we can get our 3 times 4 plus 3 times square root of 2. And then 2 times 2, which is 4. So we can get something like that. And then we are going to minus this on both sides. So mn times square root of 17 over 2 is equal to 3 times our 4 plus 3 times square root of 2 over 4 minus 3 over 2 times this as well. And then we are going to get the same denominator. This is going to be hard. So same denominator. So, and then I'm going to expand this so we can get 12 plus 9 times square root of 2. And then this is 6 minus 6 of this. 6 times our square root of 17 over 2. And then divided by 4 like that. So mn times this is going to be equal to this. And then we can simplify it way more. So we are going to multiply by square root of 17 over 2 on both sides. And divided, it should be divided. So mn is going to be equal to this. And then this looks really ugly, so we have to simplify it way more. So square root of 17 over 2 on top, multiply by this, and then 4 times 17 over 2, and then simplify. So the bottom is going to be our 34. So our final result is going to be 34. So 1 over 34 times square root of 17 over 2, and then time our 12 plus 9 times square root of 2 minus 6 times square root of 17 over 2. And then we can factor out the 3 as well. So we are going to factor out the 3. So we are going to get 3 over 34 times square root of 17 over 2 times 4 plus 3 times square root of 2 minus 2 times square root of 17 over 2. And this is just our result. mn is equal to this crazy number. So I'm going to use our calculator. What is this approximate to be? So use our calculator. Time 4 plus 3 times square root of 2 minus 2 times square root of 17 over 2. So we can know that this is approximate equal to 0.620. So this is just our question, and I hope you guys enjoy this video. Bye.